Diquat herbicide poisons the gut, may severely damage other organs, research shows. Written by Pamela Ferdinand. Diquat, an herbicide banned in the European Union but still widely used in the U.S., damages the intestines and may also trigger a harmful chain reaction in the rest of the body, injuring the liver, kidney, and lungs, according to a new review of more than 100 studies. The herbicide has traditionally been studied for its toxic effects on the liver and kidneys. However, this review, recently published, May 2025 in Frontiers in Pharmacology, suggests the intestines are a key target for its harmful effects. Studies show that Diquat weakens the intestinal barrier, kills beneficial bacteria, interferes with nutrient absorption, and triggers chronic inflammation, among other impacts. These local injuries may fuel damage in distant organs through a gut-organ axis, making Diquat's toxicity more widespread and dangerous than previously understood, the researchers say. That perspective builds on increasing evidence of the gut's central role in our health and its interactions with the rest of the body. Similarly, toxic forever chemicals that accumulate in the environment have been shown to disrupt the intestinal barrier and affect other organs. Studies show that Diquat primarily enters the body through the digestive tract, leading to poisoning, the researchers say. The core mechanism of its toxicity involves reactive oxygen species, ROS, induced oxidative stress, which not only directly damages the intestinal barrier function but also exacerbates inflammation and systemic toxicity by disrupting the balance of the gut microbiota and the normal production of metabolic products. Diquat and paraquat, toxic chemical cousins. The review coincides with mounting concerns about the long-term health impacts of pesticides, including glyphosate and atrazine, especially in children and agricultural communities. It also comes amid efforts by pesticide manufacturers to try to limit damage awards in lawsuits related to pesticide-related illnesses and deaths, and after years in which the pesticide industry sought to mislead the public about their products. Bipyridal herbicides like Diquat and its highly toxic counterpart paraquat work by generating certain types of molecules, reactive oxygen species, or ROS, that destroy cells. Diquat remains active in the environment for up to 10 days in aquatic ecosystems and even longer in soil, where it can be absorbed into soil particles and potentially enter the food chain, the researchers say. Diquat is banned in the EU, Switzerland, and the UK due to its environmental and health risks. However, like paraquat, which has been linked to Parkinson's disease and whose use is prohibited in more than 70 countries, Diquat is still used in the U.S. to control agricultural and aquatic broadleaf and grassy weeds. Applied on potatoes, rapeseed, sugarcane, and cotton, among other crops, it is also used to dry silage, fermented green crops used for animal feed, and hay for storage. Registered with the EPA as a non-selective contact pesticide, Diquat kills all vegetation that it touches. It also continues to be sold to countries like Brazil, where its usage has soared since paraquat was banned in 2020, and small-scale farmers are less likely to use personal protective equipment, PPE. Herbicide harms start in the gut. When ingested, Diquat directly damages the intestinal epithelial cells that line the gut. Some of the ways Diquat does this is by shortening finger-like projections villi and deepening small pits in the intestinal lining, impairing nutrient absorption. Generating ROS that damage tight junction proteins, weakening the gut barrier, and allowing toxins and pathogens to leak into the bloodstream. Releasing massive amounts of pro-inflammatory cytokines, proteins that worsen inflammation. Diquat disturbs the gut's microbial ecosystem, reducing beneficial bacteria like lactobacillus while increasing harmful microbes, the researchers say. It also alters the production of key microbial metabolites, depleting resources that fight disease and making it harder for the gut to repair itself. Diquat's role in the gut organ axis. Studies suggest that Diquat's harmful impact on the intestine can extend to other organs, the researchers say. In particular, kidneys. Diquat causes acute kidney injury by damaging cell membranes and activating inflammatory pathways, which causes scarring and worsens kidney function. Liver. The herbicide disrupts mitochondria, the cell's energy centers, causing cell death and promoting liver inflammation and damage. This may also trigger immune responses that damage tissues beyond the gut. Lungs. While less toxic than paraquat, Diquat generates harmful molecules that can damage respiratory tissue. Other. The herbicide may also interfere with autophagy, a process that clears damaged proteins from cells, which could lead to broader organ damage. The resulting cascade of toxic impacts may serve as a key driving force in the development of multiple organ dysfunction syndrome, MODS. Although the precise mechanisms are still unclear, the researchers suggest MODS is a life-threatening condition that occurs when two or more organ systems fail. Calls for human studies, pesticide detox methods. However, important research gaps remain, they say. Most of the studies they reviewed were based on data from rodent models, with a lack of human studies to confirm the findings. The models also did not mimic real-world, long-term, low-dose exposure. Given the gut microbiome's complexity and the influence of factors such as diet and genetics, the researchers call for epidemiological studies on populations exposed to Diquat, targeted detoxification strategies centered on the intestine, and improved models to better understand Diquat's full effects. In-depth investigation of its toxicological mechanisms remains essential for ecological restoration in contaminated areas, clinical management of poisoning cases, and toxicity assessment of structurally related herbicides, they say. Reference: HeCKG, GI, Jiang R, YX, Tau N effect of Diquat on gut health. Molecular mechanisms, toxic effects, and protective strategies. Frontiers in Pharmacology, 2025-16. doi 103389/FAR 2025 1,562,182.